Hey everybody, this is Larry. This is week 1 of the weekly premium challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. We have 2955, number of same and substrings. Don't know what that means yet? Let's read on. You're given 0 index string S and a 2D array of integers queries where query sub I is equal to L left and right, indicating a substring S from the left and right index, right? Return an array answer where answer sub I is the number of same and substrings of query sub I. What does that mean? Okay, I guess I explain next. A 0 index string T is called same index if it has the same character at both ends of the string, which makes sense. A substring is a contiguous non-empty sequence of characters within a string. Okay. So here we have 0, 0, which has only A. Second, we have 1, 4, we have B, C, A, A. Yeah, I mean, I think this is a very, I think this is a problem that definitely, if you're not practiced enough, it can look a little bit intimidating, because you have all these definitions of same and substring. But same endness is actually, can be reduced a bit, right? The thing that you would think about for this particular problem is that a same and substring, it means it doesn't matter what's in the middle. It only matters what's the beginning and the end. Maybe obvious, but then the next step is that, well, then now how do you count them, right? Well, then the count only matters. So basically, you can rethink about this instead of just substrings. You can think about, okay, well, we have strings that begin with the beginning and the end. That means that everything that's not that character, let's say we focus on A for a second, everything that's not A, it doesn't matter, right? So then now let's say we have, I don't know, 5 A's, then how do you count them? Well, if you have 5 A's and nothing in between matters, then now it's just going to be 5 choose 2, right? Maybe not, actually it's 5 square then, right? Because you can, I say the difference between 5 choose 2 and 5 square is that because you can have one character string, because that means that the beginning and the end is the same. So then now, wait, is it? Maybe it's not 5 squares still. 5 plus 4, so it's still 5 choose 2. Huh. Am I just dumb? I am dumb, probably. But I think it's like... anyway, I think it's 5 choose 2 plus n, actually. Or n choose 2 plus n, which is a little bit different from n square, I suppose. Because it's not quite... Because the order doesn't matter, so yeah. I think I messed up on that one. My apologies. But the intuition is still about the same, which is that means that now... Let's say we're only focusing on A, one character A. Then we just count the number of that characters in the query things, right? Like the query range, rather. And then the next thing after that, then, right, is that, okay, well, now we have to do it for every character. So that's just 26 characters. That's fine. But now we have to count the number of characters in a subquery range, which you can do in a number of ways. You can, depending on how you do it, I mean, 3 times 10 to the 4th is small enough that it shouldn't matter that much. But you want to pre-process it, because if you just do a linear scan, it's going to be too slow. But there are two main ideas that you can think about. One is just prefix sum, because then now for each of the 26 alphabets, then you can, do a subtraction in a prefix sum kind of way to get a count. The other way, of course, is just to store the index, and then you can do a binary search on the left and on the right. I think usually that conversation is about time versus space. Because with the prefix sum, it's going to be the size of the alphabet times n, because you need, that's just the way it is. Because you're structuring it such that, you have it for every index and every index for every alphabet, right? Letter of the alphabet. For binary search, it is actually O of n, a tight O of n, because you just store the indexes. I think normally I probably do a prefix sum, honestly, because I am used to it. But today I'll mix it up a little bit and do a binary search. It should, both things, the complexity is a little bit different, but I think like if you want to become good at this, you should be able to do either of them like very fluently. I say that, and we'll see if I actually do it rather fluently, right? So we'll see. But yeah, for first we want to pre-process the thing, right? So we have now maybe naming things is hard, but maybe P for position. Of C we append index, right? So here we have P is equal to collections.default dict of a list. So basically everything is a list in C, and of course because we're going from left to right, this is going to be already in increasing order, which allows us to do binary search. And then now we do for left right in queries. Yeah, okay. So we want to set up the answer real quick. And then now we just want to binary search for the left and the right, right? So then now we want to I always, this is something that I am a little bit weak on, is making sure that I don't get off by once. I think for the left side we can just do a straightforward bisect left, because that'll be the first index of the left index, right? And then the right index, I have to think real quick, because right is inclusive, so that means that if it is the same, we actually want to get the next one, so it should be bisect right. Of course I should spell it correctly. I think that should be it. And then answer.append is going to be all index minus left index, because all index is not inclusive, where left index is inclusive, so it's like an open quote thing. I think this should be right because you don't count the index. And that's pretty much the idea behind this one. Oh, I am dumb. I don't know what I did here. I mean I forgot to loop it on C is what I meant to do. But yeah, but basically I don't know, I wrote this, and that's why like this is funky, because C is the last. This is something that I actually don't like about Python, by the way. That, or at least I seem to make this mistake a lot, even though as soon as I did, I was like, that doesn't make sense, I'm missing something. But I just forgot because I went too fast in the talking about this, which is my apologies, my bad. But yeah, but this C actually is a scope leak kind of. I mean, in Python it's not, because it's intended and you should know better, but I should know better. But still, it leaks from here, being that this C, so then this C is actually the last character in the array, which in this case is B, which is what this answer kind of does, right? It just goes, okay, well, if this is B, then how many answers are there, kind of thing, and it kind of, yeah. Yeah, basically. I think so. Anyway, this is a little funky. This is actually a little bit. Why is this? Oh no! Oh, I misread. I always do this, but I misread the output and the expected in the reverse order. So I thought I was giving too high, and I don't understand why I would be giving too high. But this is actually too low, which is actually expected. But yeah, but then now we can do it for C in what's it called? Strings.alpha. What's it? Alpha. I feel like I need to be better about this. Strings.alpha. I guess I haven't done this in a while for whatever reason. I do want to be a little bit I can't find it, because it is something that I need to be better about in general. So I do want to fix strings lowercase ASCII lowercase, is it? Okay, yeah. It's something that I need to be a little bit better at. So yeah, so then this gives this, I think it's strings though, not string. Maybe I'm wrong. What do you want it? Okay, no, it is string then. But yeah, this just basically gives us A to Z, you know, in lowercase. And of course, this is still not the answer because we have to sum up all the characters of this. So we have something like right, and then total with all index minus index, and then that should be okay. Now we should be more confident about it being right. And dong dong dong. Oh, I'm dumb. I said the thing about I don't know today. maybe I am rushing a little bit in explaining or just coding or whatever. But I mean, we talked about this, so it's not like I don't know. I'm a little bit embarrassed. Not embarrassed. I'm okay. I'm just so tired, maybe. But we talked about this, right? This is the n squared plus, oh, sorry, n choose 2 plus n thing. Not this. So this is the number of, so okay. So let's just say this is the number of characters of C inside this thing, and that, oops, which is then now we have n choose 2, right? So total we do nums choose 2 plus nums, right? And there you go. Kinda haven't done this before. Hopefully this is fast enough. Huh, it's a little bit slow. Maybe, okay. Maybe prefix sum is the intended way, maybe. I mean, I don't know. I don't worry about it that much. Binary search is fine. But yeah. What's the complexity here, right? Well, this is linear time. This is going to be for each query, O of alpha times log n, right? For two binary searches, O of alpha, and that's where we have it. Another way, so like I said, another way to do is via prefix sum, which I'm not going to go over because you should be, you practice it, figure it out at home, upsolve it that way, just, additional free practice. But I think another way that you can consider about just also upsolve maybe, which comes up in different problems, but not this one is not necessary as you can see, but it is to pre-process also the queries, right? And what I mean by that is that here we have subarray ranges, right, from left to right. So then actually you could pre-process the beginning and the end in a way such that maybe we can keep track of all the things so that we scan it once at a time. I don't know if that really works, but these are ideas that you can be thinking about, because for certain problems it may be a little bit better. I think in this one actually it's still a little bit tricky, because then now you have to keep track of number of query, but then there are ways you can work it out with respect to range sum type things, but these are ideas to play around with. I think always be thinking about these ideas, so that for this one you don't need it clearly, but it gets your idea, your brain flowing for harder problems, right? So when you're stuck on Q2, Q3s, unknown problems, on unknown problems, or the more creative problems, it gets a little bit better. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.